In this question, we need to find out if there is a path from source to the target. If there is a path, return the least number of buses we use. If there isn't, we return -1. We solve this problem by using breadth first search. Normally, if we use BFS to traverse this matrix, we start from a single point. But this question we can see this we don't use a single point as a start. We just see the for example this route. The source is 1, station 1. So we can see this line, this route as at the start route. Then after we find out if there are other routes which that from the station of this route can reach to other route. Then we traverse to other route in this BFS. If we can find out there is target stop in other route, then we can return the least number of buses. If we can't find it after we finish traversing the BFS, then we return -1. For example, these are two examples in these questions. The first example, the source is 1, so the stop 1 is in this line, which has 1, 2, 7, 3 stops here. So because this line, this route, the bus will repeat forever. So it will start from stop 1, and the next stop will be 2 and 7, and then 1 again. In this case, we first start from 1, and then we can see if in this point if there is a neighbor for according to this stop. If there is a neighbor line we can reach to, but this point there isn't a neighbors, so we move to 2, and also no neighbors here, and we move to 7 here, and we find a neighbor line we can reach to, which is this line, and in this line there is a target stop, so it means we can reach to this target. And so in this example we start from source 1 and only use 2 buses. We can travel from source 1 to target here, and in this example 2, the source is 15. In 15, in this line, if we start from this line is there. We want to find out if there any other neighbors according to this line stops. This line has 2 stops, 15 and 19, and we know that only this line, this route has stop 15. So this route is the first route neighbor. So we can expand from this route to this the route 2. We can for example, if this is route 1 and route 2, route 3, route 4, and route 5. We start from route 4 and we can expand to route 2 now. Now we will see if there is neighbors according to the 3 stops, the 4, 5, 15. Because 15 because we came from 4, we won't go back again. So 1, we can see the route 1 and route 3 and route 5. There are no stops. No stops 4, 5, and 15. So in this case, we can't move to the target 12, the stop 12. So we will return -1. So this in this solution in this question, the high level is to find out the least number of buses from source to target. Step 1. If we want to solve the problem, because we won't traverse from directly from this matrix, the given matrix. So the first step, we need to create a graph, which we really want to use for the BFS. We don't traverse the single point in the given route, in the given matrix. We see this one route as a point, and we traverse from this one route to other route. So we need to create a graph first. The step 2 is we need to after we create the graph, we need to find out the neighbors. We need to find out every line's neighbors. In this case, we can if this route has neighbors, we can expand from this line to other route. The next step, after we start to traverse, we will see if we start BFS traverse. This is step 3, and if we expand to the route has target, then return the number of buses. If there is not a route, return -1. So this is steps we want to solve this problem. Let's start coding. First, we want to create. No, the first we need to see the corner case. If a source stop is the target stop, in this case we only return 0. No need to take bus. And then we create graph here. This is a new graph that will have the neighbors of each line in this list. This Q will help us to traverse the BFS, to finish the BFS. And also the visited array to help us deduplicate it. This array's length will, because how many routes, so this array's length will be the routes length. Now we need to start create this graph. Because in the next step, we want to find the neighbors. So we first sort each route, each array in the routes, and to help us to traverse the routes to create a graph. Now we start to create graph, but we need to use a method as common. This method will find out each line's neighbors. I is the index of the root R1, and J is the index of R2. If I and J are not out of bound, and then because they are sorted, so we can see if they have the same stop here. If they have the same stop, return true. It means the R1 and is the neighbor of R2. Else, if R1 smaller than R2, because they are this array a sorted array, so we want to increase. we want to move forward to see if there is a bigger element in R1, if the bigger element is equal to R2 element. So I plus plus, I move forward, else J move forward. After finish this, if no element, there are no same element, return false. Now we start to create this list to put the neighbors in this list. The J always start from the next root of line of I. If the root I and root J has common stop, the roots I and roots J has common stop, then we add the neighbors in the list. This root, I root, we put J into the I root, and at the same time, because J also is I neighbors, now we finish create the graph. The next step, we put source into queue. Also traverse this matrix, the given matrix roots. Because each root has different size of different stops, and so here we use roots I for it to judge if the J is out of bound. If current stop is source, we put this line into queue. And also to put this line visited. If the current stop is target, we need to initialize a target line. This is our goal. this. Then we want to record this goal, this line, into a set. After we've put this source, the first line, into queue, then we start to BFS here. If queue is not empty, we first initialize this count equals 1 because the source is not target. So we must at least we will take one time bus here. Now we first will pull out all of the lines, the routes, all of the routes from queue. This is current route. If current route contains if the current route is the target route, the target stop in the route has the target stop. Then we should return the count, which is the numbers of buses. If the current route is not the route doesn't have the stop, the target stop, then we need to put its neighbors into queue. This is the current route neighbors. This next route in this list. If we haven't visited this route, this is the first time we go to this route. Then we put it into queue. And the visited, also change the visited is true. Choose here. True here. After we finish this, we haven't found out the buses. We cannot go to the target stop. Then we return -1 here. Okay. After we finish the first for loop, we the count will count -1. Then we go to the next round to search if the target the route which has target stop.